Have you ever thought about how cool it'd be, like, if you could teach a machine to actually see?
Yeah.
Not just, like, take pictures, but, like, actually understand what's in them. That's that whole world of computer vision. And today we're taking a deep dive into a powerful tool that makes it all possible. It's called OpenCV.
OpenCV. Yeah. I mean, it's really fascinating how computer vision, like, has just become such a huge part of our lives. I mean, we don't even realize it's working behind the scenes in so many things, like smartphones and self-driving cars.
Right.
And even medical diagnoses.
Yeah, it's everywhere. It's everywhere. And get this, we're exploring all of this through a Chinese textbook called OpenCV 4G, Saidriwan, Python by Joseph Howse and Joe Minichino.
Okay.
You don't have to read Chinese to follow along, but it just shows you how globally relevant OpenCV is. So are you ready to see what this technology can do?
I am, absolutely. I mean, this book takes you from the basics to some really interesting applications.
Yeah.
So,
okay, so let's start with the foundations.
Yeah, let's unpack this.
One of the first things the book covers is how OpenCV handles images, like how it can read images, write images, and convert between different file formats, like BMP, PNG, JPEG.
TIFF, like it's almost like a supercharged version of your favorite photo editor.
That's a great analogy. And to understand how it actually works, we need to talk about NumPy arrays.
NumPy arrays.
They're the building blocks for images in OpenCV.
Yep.
They let you manipulate pixels, which are the tiny dots that make up an image.
Right.
And color channels, which control the colors.
So it's like having this digital set of tools that lets you tweak the very essence of the image at the pixel level. I'm already curious what we can do with that. The book then talks about color spaces.
Okay.
Grayscale.
Yeah.
BGR, HSV. I'll admit I'm not totally familiar with these.
No worries. Color spaces. There's simply different ways computers interpret color.
Okay.
So grayscale is pretty straightforward. It's just shades of black and white.
Right.
BGR stands for blue, green, and red.
And it's the standard color space used by OpenCV.
Gotcha.
And HSV, which stands for hue, saturation, and value. There's another way of representing color. That can be useful for certain tasks.
So why do we need to understand all these different color spaces? Does it really matter for computer vision?
It's crucial, actually. Choosing the right color space can really simplify analysis. So, for example, converting to grayscale can help with edge detection.
Oh, edge detection.
Which is essential for things like object recognition.
Makes sense. By focusing on the contrast between light and dark areas, the computer can figure out the outlines of objects. Okay, so we've got images covered. Now the book jumps into video processing.
Yes. And this is where things start to get really exciting.
Oh, okay.
OpenCV can handle both video files and live feeds from cameras.
Wow.
This opens up a world of possibilities for real-time applications.
So things like facial recognition,
exactly,
object tracking, or even analyzing athletes' movements in sports.
Yeah, all of that.
That's amazing. But then the book introduces this concept called Fourier transforms. This is where it gets a bit mind-bending for me.
I understand. It sounds pretty complex, right?
Yeah, a little bit.
It's actually a mathematical concept from the 18th century.
Wow.
But it's still relevant today, particularly for computer vision.
So how does something that old help machines to see?
Well, Fourier transforms allow us to break down images into their component frequencies.
Component frequencies?
Yeah. Think of it like taking a song and separating it into individual notes and their intensities. By analyzing these frequencies, we could apply filters, like high-pass and low-pass filters, to manipulate the image.
Okay, so what do those filters actually do?
So a high-pass filter highlights the sharp details, the edges in an image, which, as we discussed, is crucial for tasks like object recognition.
Right.
Low-pass filters, on the other hand, smooth things out, blurring away noise, and unnecessary details.
So even though it sounds complex, Fourier transforms give machines the ability to see details or blur the background, just like we do when we focus our vision.
Exactly.
That's pretty cool. And this leads us to another fascinating aspect of computer vision, depth. The book talks about how depth cameras go beyond capturing a flat image by measuring the distance to objects.
Exactly. It's like giving a machine a sense of 3D space, allowing it to understand the scene in a much deeper way.
Okay.
This depth information comes in different forms, like point clouds, which are literally collections of points in 3D space.
Okay.
And disparity maps, which are like heat maps, where warmer colors represent closer objects.
Okay, I'm trying to picture this. So it's like, imagine like a robot arm. using a depth camera to reach out and grasp an object because it can now perceive depth.
That's the idea, but there are challenges too.
What kind of challenge?
For example, the data from depth cameras often comes in a 10-bit format,
Oh, okay.
which needs to be converted to 8-bit for display on our screens.
So it's like translating between languages to make sure the computer and our screens can understand each other.
Yeah, that's a good way to put it.
Now, the book actually walks you through building a fun application with OpenCV called Cameo.
Yes!
This is cool.
Yeah, this is a great way to see how all these concepts we've talked about come together.
Yeah.
The idea behind Cameo is to combine facial tracking and image processing
Okay.
to let users try on different filters or even swap faces in real time.
Sounds like a lot of fun.
Yeah.
But also pretty challenging to build, right?
Definitely. There are technical hurdles, like ensuring smooth performance,
Right.
maintaining accuracy,
Yeah.
and handling different camera inputs.
Gotcha.
But that's part of what makes building such an app a great learning experience.
Okay, so we've seen how OpenCV handles images, videos, and even depth.
Right.
But can these machines actually understand the shapes of objects they can?
Yeah. The book goes into techniques for shape detection.
Okay.
It introduces something called the Howse transform.
Who transform?
Yeah. It's an algorithm for detecting lines and circles.
Okay.
It goes even deeper with contour detection.
Contour detection. What's that?
Contour detection is a way for machines to trace the boundaries of objects.
Boundaries.
Yeah, by understanding where the edges of an object are, the machine can then identify and understand its shape.
So instead of just seeing a bunch of pixels, the machine starts to see actual objects, like a chair,
Right.
a table, a person.
Yeah,
That's incredible.
it really is. And that's just the beginning.
Oh, wow.
Imagine a robot
Mhm.
navigating a room, avoiding obstacles,
Right.
or a self-driving car, recognizing road signs.
Right.
All of that starts with understanding the fundamental shapes that make up our world.
So we've gone from manipulating individual pixels to teaching machines to recognize shapes. This is all pretty amazing stuff.
It is. And we're just getting started. There's so much more to explore in the world of OpenCV.
Okay, I'm ready for more.
What's really exciting is the book doesn't stop at shapes. It dives into the realm of object detection, where machines can actually recognize specific objects, like a cat, a car, or even a particular brand of cereal box.
That's way beyond just like outlining things. It's like the machine actually understands what it's looking at. How does that even work?
It involves training algorithms called classifiers.
Classifiers.
Those classifiers, they learn to recognize specific objects
Right.
based on patterns and features in image data.
So it's like
Yep.
showing the machine a ton of pictures of cats and saying, these are all cats, now learn to spot them.
Exactly. The book gets into the details
Mhm.
of training these classifiers using tools like hair cascades
Hair cascade.
and LBP cascades.
Okay.
Those might sound a bit intimidating,
Yeah, a little bit.
but they're essentially like templates or blueprints
Okay.
that the computer uses to quickly spot patterns that often indicate a face
Hmm.
or other objects.
So I'm starting to get the idea of training a classifier, but how do you make sure that it's not just memorizing those specific cat pictures?
Yeah.
How does it learn to recognize any cat, even in a new picture that it's never seen before?
That's a great question. You're right. We don't want the classifier to just memorize specific images.
Right.
We want it to generalize and recognize the underlying features of a cat.
Right.
That's why it's crucial to train it on a wide variety of images.
Okay.
Cats in different poses, different lighting, different backgrounds. The more diverse the training data, the better the classifier will be at recognizing cats in new situations.
It's like showing a detective photos of a suspect from every angle in different disguises to make sure they can spot them no matter what.
That's a perfect analogy. And just like a detective, these classifiers need to be tested and refined to make sure they're accurate. It's not a one-time setup. You need to constantly evaluate and improve their performance.
So as these classifiers get better, what kind of real-world applications start to open up?
Well, think about security systems. That can automatically identify suspicious individuals or retail stores that can track customer behavior and preferences.
Yeah. The possibilities are pretty mind-blowing. And it's not just about static images anymore. The book also talks about object tracking, where machines can follow objects as they move within a video or a live feed.
That's right. Object tracking takes things to a whole new level.
Okay.
Imagine a self-driving car that can track pedestrians, cyclists, and other vehicles, predicting their movements and making split-second decisions to avoid collisions.
Or a security camera that can automatically follow a suspect, capturing their every move.
Exactly. The book delves into various algorithms that make this possible, like mean shift tracking and cam shift tracking.
Okay.
These are really sophisticated techniques that take into account the object's color, shape, and motion to accurately track it.
It's like giving machines a sixth sense, the ability to anticipate and react to the world around them. I'm really starting to see how this technology could change the way we live and interact with the world.
It's truly transformative. And then the book goes even further, introducing us to augmented reality.
Augmented reality.
We're talking about overlaying digital information onto the real world.
Right.
You know, like those games where you catch virtual creatures in your actual neighborhood.
Oh, yeah. I've seen those. It's wild how they make those virtual creatures look like they're really there.
That's the power of augmented reality.
Yeah.
And OpenCV plays a key role in making this possible. It provides the tools to track objects and markers in the real world, allowing us to seamlessly blend the digital and physical realms.
So you're saying we could point our phones at a building and see its history, reviews, maybe even virtual tours, all overlaid onto our live view.
That's just the beginning. Think about the possibilities in education, where students can interact with virtual objects in a real-world setting.
Oh, wow.
Or in healthcare, where surgeons can use augmented reality to guide their procedures.
Wow, it's like stepping into a science fiction movie where lines between reality and the digital world are blurred.
And it all boils down to the ability of machines to see and understand our world, thanks to tools like OpenCV. Now the book takes us even deeper into the rabbit hole by exploring artificial neural networks and deep learning.
Okay, this is where it gets really futuristic.
It might sound intimidating, but the book breaks it down in a way that's surprisingly easy to grasp.
Okay.
It explains how neural networks are essentially layers of interconnected nodes that process information.
Okay.
They learn from data and make predictions based on what they've learned.
So you're basically feeding the machine tons of data and letting it figure out patterns and connections on its own.
Exactly. And deep learning takes this to another level.
Deep learning.
It involves using neural networks with many, many layers, allowing them to learn incredibly complex patterns.
I can imagine a machine analyzing medical images and detecting subtle signs of disease that even the most skilled doctors might miss.
Or a machine that can translate languages in real time, breaking down communication barriers between people from different cultures.
The implications are mind-boggling. The book mentions specific examples of how deep learning is used in computer vision, like image classification and object recognition.
It was basically like supercharging those classifiers we discussed earlier.
Right.
Deep learning gives them the ability to recognize an even wider range of objects with even greater accuracy.
So from manipulating simple images to this incredible world of deep learning, this book has taken us on a wild ride through the potential of OpenCV.
Yeah, and it's not just theory. The authors include practical examples and code snippets throughout the book.
Oh, wow.
Give you the tools to actually implement these techniques yourself.
So it's like a workshop for aspiring computer vision wizards.
Exactly.
What's the most surprising thing you learned from the book?
You know, I was really fascinated by the discussion of color curves.
Color curves.
Yeah. It delves into the subtle art of color manipulation, essentially. Color curves allow you to fine-tune the brightness and contrast of an image by adjusting the relationship between input and output color values.
So it's kind of like having a digital darkroom where you can tweak the shadows, highlights, and midtones to create the perfect look.
Exactly. And what's fascinating is that this concept, which has been used by photographers and graphic designers for years, can also be applied in computer vision.
Oh, interesting.
For instance, imagine a security camera that can automatically adjust its color settings based on the lighting conditions to ensure the best possible image quality.
That's really interesting. It's not just about artistic effects. It's about improving the performance of computer vision systems in real-world situations.
Right.
So we've covered a lot of ground here. We've seen how OpenCV handles everything, from basic image manipulation to complex tasks like object recognition and deep learning.
And we've also seen how this technology is not just theoretical. It has real-world applications. They're already changing the way we live, work, and interact with the world.
It really is amazing to see how this technology is evolving. You know, from those individual pixels to systems that can recognize objects and even learn on their own. Is there anything else from the book that particularly caught your eye?
Yeah. I found the section on building a basic facial recognition system. Really fascinating.
Facial recognition, that's something we hear about all the time, but I don't really understand how it actually works.
That's a powerful capability, that's for sure.
Yeah.
Imagine security systems that can grant you access based on your face.
Wow.
Or social media platforms that automatically tag your friends in photos.
Yeah, it's like giving machines the ability to recognize people, just like we do. So how does a book approach this?
It breaks down the process step by step.
Okay.
Starting with finding faces in an image.
Okay.
And then moving on to identifying specific individuals.
Right.
It explains how to train a system using something called hair-like features.
Hair-like features?
Imagine looking at a face and noticing the contrast between the eyebrows and the cheeks. Hair-like features, or essentially patterns like that, but defined by a computer.
Okay.
They help the system quickly scan an image and identify areas that might be faces.
So it's like giving the machine a set of rules to quickly scan an image and say, hey, this looks like a face. Let's take a closer look.
Exactly. And to take it further, the book explains how to create a cascade classifier.
A cascade classifier?
Which efficiently narrows down the search for faces.
Okay, what does that do?
Think of it like a series of checkpoints.
Okay.
At each checkpoint.
Yep.
The system checks for certain hair-like features.
Gotcha.
If it finds them. It moves on to the next checkpoint.
If not.
It quickly discards that area of the image.
Okay.
This helps the system process images much faster.
That's clever. So how does the system actually learn to recognize specific people?
Well, that's where the concept of machine learning comes in.
Machine learning.
You train the system on a set of known faces, essentially giving it a yearbook full of faces and names to study.
So the machine learns to match those faces with the correct names. And the more data you give it, the better it becomes at recognizing those faces in new pictures.
Precisely. That's the beauty of machine learning.
Yeah.
It's a continuous learning process. And it's not limited to facial recognition. It can be applied to a wide range of computer vision tasks.
You know, I'm remembering all those sci-fi movies where they like reconstruct a 3D scene from a blurry security camera footage. Is that something that's actually possible with OpenCV?
It is.
It is.
The book even touches on 3D reconstruction using a technique called Connect Fusion.
Connect Fusion.
This technique allows you to create a 3D model of a scene using data from a depth camera, like the Microsoft Kinect.
So it's like giving machines the ability to see the world in all its 3D glory instead of just a flat image.
Exactly.
Are there any real-world applications for this?
Absolutely. Like what? Think about robots that can navigate complex environments.
Okay.
Or architects who can create virtual models of buildings. Even doctors can use 3D models for surgical planning.
It's like bringing the digital world into the real world and vice versa. It really blurs the lines between what's virtual and what's physical. So we've learned about manipulating pixels, recognizing objects, and even reconstructing 3D scenes. This has been a wild journey through the world of OpenCV and a computer vision.
It has been an incredible journey, and it all comes down to machines being able to perceive depth, understanding the spatial relationships between objects. OpenCV is making that level of perception increasingly accessible.
You know, I'm left thinking about the future. Like, what if machines could not only see, but truly understand the world around them, anticipate our needs, solve complex problems, and even augment our own abilities? It's both exciting and maybe a little bit unsettling, right?
It is. And it's a future that's rapidly approaching. Tools like OpenCV are paving the way, this deep dive. It's giving you a glimpse into that future.
It definitely has. This book and our discussion today have really opened my eyes to the incredible potential of computer vision. It's clear that this technology is going to continue to shape our world in profound ways. Who knows? Maybe some of our listeners will be the ones developing the next groundbreaking OpenCV application. The possibilities really are endless.